In this first question, I am asked to find the voltage, and I'm given this little piece of a circuit right here, and I'm just going to use Ohm's law, V equals IR. So I do not know the voltage, but I know that the current, it says right here, I is, of course, current is 1.4 milliamps. A milliamp is a thousandth of an amp, so I have to move the decimal point 3 places over. So I'll write that as 0.0014, right? I moved the decimal 3 places over, times my resistance. Now my resistance is 22 kilo, that's times 1,000, right? So I will write 22 with 3 zeros, and stick it in your calculator. 22,000 times 0.0014 gives you a voltage of 30.8 volts, and that's already in engineering notation, right? I have two numbers in front of the decimal point. That's perfectly acceptable. So my voltage is 30.8 volts. I'm asked to find the current, right? I is current in this particular series circuit, and I'm just going to use Ohm's law again. Hey, what could be better than that? V equals IR. I'm given my voltage is 9, so I have 9 volts. I am looking for current and resistance. These are all in series, so I just have to add these up. 470 plus 1.2 kilo, that's 1,200. Plus 270, and that gives me 1940. I just stuck those in my calculator. Now I just have to divide both sides by 1940 to find current. 1940, 1940, and that gives me, that gives me a current, or I, of, I'm just putting this in my calculator, that's 0.00463 9 and so forth. Well, that's a lot of decimal places. I'm just going to round it to 2 places. Now this is not correct engineering notation, right? I have to move it 3 places over. So that gives me 4.63. I'll call it 4.64. 4.64, and that is milliamps, right? I moved it 3 places to the right from the unit, 3 places to the right. We've done that before. And that's my final answer. This next one is a little bit tricky. I have a lot going on here. Again, I'm trying to find the total current, and I'm going to use, of course, V equals IR again. I can just write that down. But in order to find the resistance, these guys, of course, are in parallel, so I have to use that rule for adding in parallel, which is 1 over the first guy. Now, this is kilo ohms, so that's really 8,200. Plus the next one is 1 over, again, kilo ohms, so that's 6,800, plus 1 over, again, kilo ohms, so that's 4,700. And if I put that in my calculator, I end up with a total resistance, call it R sub T, of 2075. And there's a whole lot of decimal places. I'm just going to round to like maybe 4, 6, 5, 3, 4. It's always good to go like more decimal places along the way and then do your final rounding at the very end. So that's my total resistance. And I think I have everything else I need. I have a voltage, which is 12. So V equals I. I'm looking for that. And my resistance, is 2075.6534. If I divide both sides by that, I end up with a current of, I'm putting this in my calculator, of 0.0005781 actually. And a bunch more decimal places. So this is not correct engineering notation yet. Again, I'll move it 3 places over, right there. And I end up with 5, and I'll just round to 2 places at this point, 5.78 amps. It's a little tricky because of all the engineering notation and stuff like that you have to do. Little error right there. It's 5.78 milliamps, right? Because I moved the decimal point over, so I could squeeze in 5.78 milliamps, right? Hope that makes sense. In this question, I am asked to find the voltage drop across resistor R1. So here is resistor R1, and I'm given that the resistance is 220 ohms. I think in order to do this, it would be easiest, and there's probably more than one way to do this, but it'd be easiest if I found the total current first. So I'm going to use Ohm's law, which I love to use, V equals IR. I'm given the total voltage is 12 volts. I'm going to find the total current, and the resistance, well, I just have to add all these up to find the total resistance. So that's 220 plus 470, right? These are just in series. I just add them all up, plus 1.2 kilos, so that's 1200. So that gives me a total resistance, I'm just putting this in my calculator, of 1890. So let me just put that right here. My total resistance is 1890. And if I divide both sides by 1890, right, 12 over 1890, that gives me a current of, it's going to come out to some long decimal number there, but it's 0.006349. It keeps going, but that's close enough. So that's my total current, and I hope you follow what I did there. I'm just using V equals IR. I had to get the total resistance, divided both sides by that, got my total current. So now I can use this to find the voltage drop across any of these resistors, and I'm going to use it to find the voltage drop across resistor R1. I'm going to use Ohm's law again. V equals IR. I'm looking for the voltage drop across this guy. That's voltage. I know that the amount of current running through here, because this is in series, so the amount of current is the same through this whole loop. So I'll use that number that I just calculated, 0.006349. And notice I'm not converting it to engineering notation because I want the original decimal number in the equation. So that times the resistance, which is 220, and I end up with a voltage drop of 1.3968. It keeps going, but let's round it to two places. So let's call it a voltage drop of 1.40 volts. Now, if you had calculated the voltage drop across this guy and the voltage drop across this guy, altogether, they should add up to the total amount of voltage, right? In series, the total amount of voltage produced is equal to the total voltage drop. So you could do that and check to see if they add up to 12, and in fact, they should. All right, number 5, this is it, and the trickiest one of them all. So here I have a parallel circuit, and I'm given the total current is 108 milliamps, and actually I'm just going to write that in amps just so I don't mess up. I know if I'm going to put it in the equation, I've got to convert it to its decimal value. Oops, 108 amps. Okay, so that's my total current, and I'm asked to find the resistance of R1. I'm asked to find this resistor right there. Well, I got a bit of work to do here. Now, I know that this is a parallel circuit, and I know that the amount of voltage drop across each of these branches must be equal to the total voltage drop. In other words, this is a 15 volt drop across this resistor, 15 across this resistor, 15 across this resistor. Remember, voltage is how much energy each individual electron has. So if I have electrons starting out here with 15 volts, it has to lose all of his energy by the time he gets home. So if he goes this way, he's lost all 15 volts through that resistor. If he goes that way, he's lost all 15 volts, or through that resistor. 15 volt drop across any of these resistors. So I'm going to use that first to calculate the current in each of these little branches right here, just using Ohm's law. V equals IR. What could be better than Ohm's law? So I'm looking for the voltage drop. Oh, I'm sorry, I have the voltage drop. It's 15, right? 15 across each of these. I'm looking for the current in this little branch here, and I know the resistance, it's 2.2 kilo ohms. So I'll write that in decimal form. So that's 22, right? I got to move it over 3 places. 2200 ohms. Divide both sides by that. I have a current in this little branch of, I'm putting this in my calculator, 0.006818. Now it keeps going, but whatever. So that's my current in this little branch right here. I'm going to do the same thing to find the current in this little branch right here. V equals IR. I think I'll be able to squeeze it in. Voltage is 15. Maybe I'll write it up top. So my voltage is 15. Again, that's my voltage drop. I is what I'm looking for. The resistance is, I'll write it in decimal, so it's 3300. Divide both sides by 3300, and I get the current in this little branch of, just sticking in my calculator, 0.004545. I'm rounding, of course, 4545. It keeps going. So I know the current in this branch. I know the current in this branch. I don't know the current in this branch, but I know that they all add up to the total current. So if I subtract, if I have 0.108 amps, and I subtract these other two guys, if I minus the current in the first guy, that is 0.006818 amps, and I subtract the current in the other branch, 0.004545 amps, I am left with a current of, and I'm putting this in my calculator, of 0.96637 amps. That must be the current in this branch right here, right? Because all of these little currents, they all come together into this current, right? The total current, obviously. All right, almost there. I just have one more little V equals IR equation for this thing, which I'm looking for the resistance. I know the voltage drop, so I'm going to do V equals IR. The voltage drop is 15, the same voltage drop every place. The current I just figured out must be 0.096637. I'm looking for the resistance, so if I divide both sides by 0.096637, I get a resistance of 155.22, and I'm rounding a little bit. That's my resistance in ohms, and that's it. So you have to know a little bit here, right? You have to know that the voltage drop across each of these branches is the same. It's 15 volts. And you have to know that the total current is equal to the sum of the currents in each of these branches. And again, I hope that makes sense, because current is really the number of electrons that are flowing through my circuit. So if I have, 108 milliamps worth of electrons flowing through this main branch, some are going this way, some are going down here, some are going down there. Now again, it doesn't matter which way you think of it. If you think of them as flowing the other way, that's really fine too. But the sum of these currents must be 0.108 amps, of course. And I used that to find the current in this branch, and then I used V equals IR to find the resistance. Now, that's a tricky one, but I think you can handle it.